Welcome to qnawire.
All right, we've got a stereochemistry question here. And copy down the first molecule. And we are kind of in luck here because I'll note we have hydrogen in the back. Whenever we have hydrogen in the back, all we need to do is the following. We determine the priority of each of our substituents, not including hydrogen, or really it's not just for hydrogen, it's whenever our lowest priority substituent is in the back. I should be more specific. But if our lowest priority substituent is in the back, which in this case is clearly hydrogen, we simply need to label the priority of the remaining substituents. Oxygen would be the highest priority, carbon attached to oxygen would be the second highest priority, and a methyl group would be the third highest priority. And at this point, we simply connect the highest to the second highest to the third highest with a line or circle, and then determine whether that is clockwise or counterclockwise. In this case, that is clockwise. And if the lowest priority substituent is in the back, clockwise corresponds to R. If the lowest priority substituent is in the front, then clockwise is S. Okay. So the first one is R. Let's move on to the next. Okay. And what is implied here, but not explicitly shown, is that there is a hydrogen in the back of each of these, right? Because carbon must have 4 bonds. If 3 are shown, we fill in hydrogens for the rest. All right, so now let's label the priority of the substituents on this first carbon. Note that there are 2 stereocenters here, right here and there. Okay. Oxygen is the highest priority. Okay, carbon attached to oxygen is the second highest priority, and then carbon is the third, and hydrogen is the lowest. And this would be, if we connected them 1, 2, 3, that's clockwise. And clockwise corresponds to R. So this is R on the left. And if we repeat the process, but for this other carbon now, oxygen is the highest, carbon attached to oxygen is the second highest, and actually, this one's a little trickier than that. Okay, oxygen is the highest, but now we're comparing this carbon to this carbon. The one on the right is doubly attached to oxygen. So we would actually classify this one as being attached to oxygen, and carbon. Whereas this one, we would classify as being attached to oxygen, carbon, and hydrogen. And so this would win out, actually. So in terms of priority, the carbon doubly bound to oxygen is a higher priority than the neighboring carbon on the left-hand side. So this is priority 2, and this is priority 3, and hydrogen in the back is 4. Now, if we connect 1 to 2 to 3, we find that it is clockwise, and given that our lowest priority substituent, the hydrogen, is in the back, then clockwise corresponds to R. Okay, so we can specify this stereochemistry as being R, comma, R. All right, let's move on to the next one. Got like a cyclopropane thing here. Okay, again, implied hydrogen, this time in the front over here, and an implied hydrogen in the back over here. Assign the priority. Let's start over here. Chlorine's going to be the highest, carbon attached to chlorine the second highest, carbon the third, and hydrogen the fourth. And if we connect these 1 to 2 to 3, we find that this is clockwise. But note, the lowest priority substituent is not in the back. Doesn't necessarily have to be in the front. Anywhere but in the back means that clockwise corresponds to S in this case. Okay, let's move on to the next one. Again, chlorine is the highest priority. Carbon attached to chlorine is the second. Carbon not attached to chlorine is the third. And hydrogen is the lowest priority, and that's in the back. If we go 1, 2, 3, now we've got counterclockwise. Sorry, not clockwise, counterclockwise. And if our lowest priority substituent is in the back, then counterclockwise corresponds to S. So this molecule in total is S, S.